Hello everyone, mabuhay! You're about to watch Research Lecture Series. Please don't forget to subscribe to my channel, hit the bell icon so that you will be notified with the upcoming series. You may also share the link to your students, classmates, or friends. Enjoy watching! This is a research spectrum that presents a snapshot of the entirety of this research lecture series. In Series 1 to 3, the first tier or level was presented, particularly the meaning, nature, and classifications of research. For Series 4 to 6, the second tier, which is research methods, shall be discussed. For this fifth series, the quantitative research method shall be dealt with exclusively. This series aims to present the meaning, nature of quantitative research, its purposes, sources of data, mode of data collection, and strengths and weaknesses of quantitative research. Quantitative research is a type of investigation in which data are presented in numerical format and summarized into tables, graphs, and figures. According to Zarabi, quantitative research report is usually presented in numerical forms along with relevant tables, diagrams, and figures. Creswell describes it as analyzing trends, comparing groups, or relating variables using statistical analysis and interpreting results by comparing them with prior predictions and past research. Glenn expounds that quantitative approach is used when one begins with a theory or hypothesis and tests for the confirmation or disconfirmation of that hypothesis. He further elaborated that quantitative designs include experimental studies, quasi-experimental studies, pre-test, post-test designs, and others where control of variables, randomization, and valid and reliable measures are required, and where generalizability from the sample to the population is the aim. Mowich states that quantitative research is concerned with explaining phenomena by collecting numerical data that are analyzed using mathematically based methods, in particular statistics. In contrast to qualitative method, whose aim is to answer what, how, or why of a phenomenon, example COVID-19, quantitative method answers how many or how much, such as how many individuals were greatly affected, moderately affected, or least affected by the new pandemic, or how much damages has it incurred to those afflicted. On the other hand, quantitative research is best in A. Presenting a snapshot of the current states or trend, B. Confirming findings of exploratory studies, C. Testing hypotheses, and D. Estimating parameters. First, to present a snapshot on the current states or trends. Quantitative research is more appropriate in presenting a snapshot of the current state or condition of the subject being investigated in a condensed format, and the results can be summarized in numbers, most often arranged in tables, according to Hub. He further added that the essential movement of the research is the reduction of large amounts of distributed information to numerical summaries, means, percentages, correlation coefficients, etc. Regin, cited in Hub, remarked that quantitative researches are data condensers, as they present summary characterizations, and qualitative are data enhancers since they try to explicate webs of meanings. An owner of a school, for instance, is interested in knowing the current states of the institution may commission a research project to provide the information needed, such as population, income, national achievement tests, rankings among competitors, and other variables. The research findings would be best understood by the owner or by anyone else when the information or data are presented in tabular or graphical format. Second, to confirm findings of exploratory studies. Quantitative researches aim to confirm the baseline information presented in an exploratory research. In order to make the information or data conclusive and generalizable, a follow-up study is needed in the form of quantitative research wherein more respondents are recruited to confirm the information generated in the qualitative research. The representativeness of the sample to the population is essential in the generalizability of the results, which can be determined using statistical computations and can be drawn using probability sampling techniques. For example, the symptoms such as intermittent fever, chest pains, dry cough, sore throat and rashes, and loss of taste or smell were determined in case study of 10 COVID-19 suspects were validated from a bigger sample of patients admitted in healthcare facilities. In the latter case, the findings is more conclusive as compared to the anecdotes obtained from few suspects. Third, to test hypotheses. Quantitative research is used in testing hypotheses. According to Glenn, hypothesis is a suggested explanation of a phenomenon, or alternately a reasoned proposal suggesting possible correlation between or among a set of phenomena, which are either a suggested explanation for an observable phenomenon or of a reasoned proposal predicting a possible causal correlation among multiple phenomena. Hypothesis results remain provisional, which should not be considered as absolute truth. This view is known as method of conjectures and reputations, which means that there is always a possibility that future researchers will affirm or arrive at different findings. There are two types of hypotheses that can be statistically tested: the hypothesis of association and the hypothesis of difference. The first is typified as correlational research. It attempts to establish association between two variables or between variable and several variables, as well as the direction of relationship. Creswell, in a previous book, 2012, he further explains that the degree of association expressed as number indicates whether the two variables are related or whether one can predict another. Martin and Bridgman expound that in correlations research, an independent variable is often called a predictor variable, and a dependent variable is called a criterion variable. A variable is a trait, characteristic, or condition that can be manipulated, controlled, or measured with two or more categories. A category is a division or classification of variable. Example, the variable sex has two categories, male and female. Dependent variable is a variable that is measured in an experiment and is presumed to vary as a result of manipulations of the independent variable. It is assumed that the independent variable, example, remdesivir, causes change in the dependent variable, such as COVID-19. An intervening variable, also known as mediating variable, is another independent variable that mediates or stands between the independent and dependent variables and exercises an influence on the dependent variable in addition to the independent variable. Extraneous variable, also known as confounding or spurious, is another independent variable that seems to influence the dependent variable. The researcher can only detect its existence and measure its extent of influence to the dependent variable after statistical treatment, particularly during the analysis of results. To illustrate, the test scores or dependent variable of student could be influenced by the number of hours in reviewing lessons or independent variable. An IQ is an extraneous variable that influences or may compound academic performance. Environmental condition is an intervening variable that mediates for a better absorption or disruption of learning. The other type, hypothesis of difference, is used in making a prediction about changes expected between or among groups. In quantitative investigations, researchers often test theories expounded by previous authors. For instance, a math faculty researcher may test a prediction that male students score higher in math than females as previously theorized in the literature. The findings of the new research may affirm or negate the theory or the findings. A probability that is built into theory, that is, it could be applicable to some but not to others. The theory could be true at the moment, but it could also be different in the future. Fourth, to estimate parameters. Quantitative research is used in estimating parameters. Conducting a research using a census or a very large sample is not only expensive but also time-consuming. Hence, a desirable amount of sample could be used as respondents or subjects of the study. When the number of samples is dismally low, it may pose problems in drawing statistical conclusions. When a good representative of the population is drawn, results that will be generated could be as good as the findings obtained from a bigger or from an entire population. This means that findings obtained from the sample can be used to make a generalization of the entire population. The conduct of investigation is even more difficult when the population is unknown. An appropriate formula is employed in determining sample size when the population is not known. Parameter estimation is concerned with finding the value of a population parameter using the value obtained from the sample. Glenn recommends quantitative design when generalizability from the sample to the population is the aim. Martin and Bridgman adds that inferences about sample statistics such as mean and standard deviation are used to estimate population parameters. Further, the use of probability sampling allows the researcher to come up with a valid generalization. Probability sampling, of which simple random sampling is the most familiar example, allows the investigator to generalize results of the study from the sample to the population from which it was drawn, affirms Merriam. The most common sources of data for quantitative studies are individuals, groups, who serve as respondents for surveys, as participants for experiments, assessment and evaluation, and as subjects of observation. The other sources are objects, equipment, institutions, or organizations which could also be subjected to appraisals, observation, assessment, or evaluations. From these sources of data, A researcher could obtain the following. First, respondents' views about an issue, current condition, or trends through surveys using questionnaires. Example, couples' view on compatibility, Catholics' opinion on the implementation of death penalty, consumers' buying capability, or election polls. Second, assessment of current states or condition through written or actual testing. Example, level of proficiency of welders, extent of readiness of senior high school teachers, level of competency of elementary graduates. Third, experts' appraisal of the value or condition of an object or human subjects through diagnosis or inventory. Example, durability and efficiency of a new gadget, condition of victims of food poisoning. Fourth, evaluation on the impact or effect of a program or an intervention through an evaluation instrument. Example, effect of a new drug among cancer patients, impact of the government's Pantawid Pamilya program among the recipients. Fifth, results of an experiment. Example, effects of classical music to learning, effects of papaya leaves extract in the treatment of dengue fever, which are all subjected to statistical treatment. Modes of data collection under quantitative research. The common data collection processes for quantitative research are surveys, assessment, appraisal, evaluation, and experimentation. To illustrate, surveys are regularly conducted on the trust ratings accorded to the President by the citizens chosen on a cluster sampling technique. Another example is an assessment conducted to determine the level of aptitude of students, which could be used as basis of assigning sections. Further, applicants for particular jobs, especially those that require skills, are assessed through demonstration or through a test. Moreover, the effectiveness and efficiency of a LED lamp is best obtained through repeated trials. Finally, the value of an object such as fossils or artifacts is best determined through appraisals. In quantitative research, the quality of raw data is essential. If the data are not cleaned thoroughly, statistical calculations will be either wrong or of inferior quality. High-quality raw data is also determined in selection of appropriate mode of data collection. Many academic researchers prefer surveys for convenience, but the data obtained may not be necessarily of high quality due to some limitations of this technique, such as social desirability or halo effect. A research on a student's academic performance, for instance, is not reliable when a survey is used asking the respondents to indicate their grades. The student may not be able to recall the actual grades, especially when the scores are not very recent. A social desirability bias or Hawthorne effect is likely to happen when the underperformers report ratings higher than what they have actually obtained. The survey is also vulnerable to halo effect, in which an outstanding characteristic of the subject affects the subsequent ratings of the respondents. As such, a better data collection technique is data retrieval of the actual grades of students from records archived or from the teachers of the students. Strengths of quantitative research. Quantitative research is numerical, in which data are presented in tables, graphs or figures with the researcher's concise presentation of the scientific results, which are objective, systematic, orderly, clear, and accurate. Quantitative research presents results as quantities or numbers. Patten describes that the basic features of the design are oriented to quantifications, which he calls it numerification. In quantitative research, large amounts of data are presented in concise numerical summaries such as means, percentages, and other sophisticated statistical computations with corresponding adjectival interpretations. Martin and Bridgman added that essential statistics methods used to assess scores of variables include central tendency, variability, and the characteristics of the normal distribution. Reliability is one good feature of quantitative research. It is the extent to which repeatedly measuring the same property produces the same result. Hence, the procedures employed in the study must be made known to the public through publication and conference proceedings. Prainkel and Wallen suggest that all aspects of investigation are described in sufficient detail so that the study can be repeated by anyone who questions the results, provided of course that those interested possess the necessary competence and resources. Objectivity is another good feature of quantitative research. This means that the researcher needs to be as detached from the research as possible and use methods that maximize objectivity and minimize the involvement of the researcher in the research. Nyesriadomi supports this by saying that researchers' opinions and personal biases should not influence the findings of the study. Creswell recommends that being objective is an essential aspect of competent inquiry. Researchers must examine methods and conclusions for bias by applying the standards of validity and reliability. Other than being objective, quantitative researchers discuss results in a systematic, orderly, clear, accurate, and interesting. According to Raswadomi, scientific research uses empirical data or data gathered through the senses and is a systematic, orderly, and objective method of seeking information. Grizzly advised that the key criteria for good scientific writing are accuracy, clarity, and structure, but you should also try to make it an interesting story rather than a dry listing of statistics and outcomes. A scientific research requires longer time of administration. Hebb cautions that doing scientific work takes time. One needs time to collect evidence, read the relevant literature, think through one's argumentation, and compose a convincing report. ends our research lecture series for today. Don't forget to subscribe to my channel, hit the bell icon, and share the link to your students, classmates, or friends. Thank you for watching.